Okay, so what is a vector? Okay, vector basically made up with two components or two you can say two things. Okay, firstly it has magnitude, basically the length, and the direction, which direction. Let me draw a 2D geometry on the paper. Okay, so this is our x-axis, we know, and this is y-axis. Okay, sorry, I just draw a pretty horrible. Okay, so let me draw one more time. So this is our x-axis and this is our y-axis. Okay, let's suppose we wanna, okay, we wanna move a point, okay, or game object, or some like a player game object, you can say. Okay, so we wanna move that from this is one, this over here, okay, is 0 comma 0. We know it is start from 0 comma 0. Okay, so this is our 0 comma 0, and we want to move, let's suppose over here we have player, and we want to move something like over here. Okay, something like over here. So how we can do that? Basically we will draw a line from that point to this point. Okay, let's call this point this middle point, or 0 comma 0 is A. Okay, and the point we want to move is a B point. Okay, B point, as you can see. So firstly what we need the x, we know, vector basically over here, vector. Okay, vector, sorry, I'm terribly drawing. Okay, I apologize for it. So vector, we know it has x-axis, okay, and y-axis. Okay, so x-axis, as you can see, we will start from the 0. Okay, start from the 0, and let's suppose this length over here, we move to the x-axis, something like, let's suppose 5. Okay, so let's suppose we move to the x-axis 5. uh, 5. Oh, okay, so the x over here will be 5. Okay, 5. So the x is 5, so this length, basically we move it over this length in the x-axis is 5. We go on to the x-axis 5, and then we gone to the y-axis. Let's suppose this one is 3. Okay, this one is 3. So the we have gone to the x-axis 5 and to the y-axis 3. Okay, so basically we need add this vector, okay, to any game object we want to move. So we need to add this length or this vector to that game object, so that game object will move to the A point to B. So, and we know vector is vector to basically vector. So we now, for now, we will use a vector 2. Okay, basically which holds two pieces of data. Okay, and later on we will go into 3D vectors. Okay, let's suppose 2D vectors, and we know a vector has x-axis and the y-axis. As you can see, this is our x length and this is our y length. And let's suppose you wanna just wanna get the length of this vector. So how you can do that? So as you can see, or it's an right angle triangle becomes, it became an right angle triangle. And let's suppose the length over here we don't know, so let's assume this the length of is C, and we do know we can find the length of that vector by using Pythagoras theorem. We know we can use x something like a square plus b square equal to c square. We know this is an right angle triangle, so we can find this length of this vector. So what we have to do, we know the theorem is that c square equal to, okay, x square. So let's assume this one is x square. Okay, x square plus y square. Okay, y square. Let's assume this one is y. Okay, this one is y and this one is x. And let's do over here on the another page. So we know x c square, sorry, c square equal to x square plus y square. Okay, and we don't know the c square, so let's c square equal to x. We do know this, as you can see, x is 5, so over here we will put 5, so 5 square, okay, 5 square plus the length y, as you can see, 3, okay. So let's pass over there 3, so 3 square, 3 square. I'm just horribly drawing. I apologize for that. Okay, so the c square will be equal to 5 square, we know, which is 25, okay, 25, 25 plus 3 square, we know, which is 9, okay. So the c square over here will be, so if you just add up, which will be 34, I guess, 34. So the c over here will be root over of, okay, so root over of 34, and you just have to calculate, okay. You will get the value over here, something like 34, okay. So just calculate it and you're gonna get the length of it. So if we go to over here, okay, so the length of over here is 34, root over of 34. We get the length of that vector, root over of 34. So you can find length of any vectors by using Pythagoras theorem, which says x square plus y square equal to c square, okay. C square, as you can see, and it vector has a direction, okay. So that is the cool thing, and you can draw this vector anywhere in the 2D geometry, like over here, over here, and over here. Just you can move this vector anywhere in the in your 2D geometry, okay. 2D geometry. Let's solve one more example, okay. So let's suppose over here this is our vector, okay, this is our vector. Let's suppose this one is length is 3, okay, and the base length is let's suppose this is 4, okay. So we have to find this the length of it, okay, the length of it. So how you can find that? And we know, as you can see, this is an right angle triangle, so we can apply Pythagoras theorem, which says let's this base over here is x, okay. So for this one is x and this one is y, okay. So we have to find, let's assume this one is z, okay, this one is z. So we have to find, so we know the Pythagoras theorem said z square equal to x square, okay, plus y square. Basically the base square and the y square equal to z square, okay, as you can see. And we can find this, we can put the value. So z square, so x over here is 4 and 4 square, so 4 into 4 will be 16. So let's put over here 16, and y square, y is 3, as you can see, 3. So 3 square becomes 3 into 3, which is 9, okay. So let's put 9. So z square equal to, so over here z square will be 25, okay. And we have to find the z, okay. So let's put out this square. So this will be root over 25, and we know root over of 25 is 5. So the z over here, okay, z over here becomes 5, as you can see. So the length of this vector is 5, and the direction is over here, okay, this direction. And you can move this vector anywhere you want, okay. So that is the cool thing. You can find the length of that vector, okay. Something like if I draw x axis, okay, this is our x axis, y axis, and the middle point over here is 0 comma 0. And you can take this vector, okay, you can take this vector, you can just draw this vector anywhere you want to this, to the geometry or x-axis y-axis graph, okay. You can, so that is the cool thing. So you can just add this vector to any game object, okay, and it will this vector will move that game object the point you want to go, okay. So you can find the vector length, and we know vector 2 in the game or in game development Unity. Okay, so we know it has x comma y. Okay, x comma y. So this is the vector, and we have to sum of them. Okay, you can find the length of that vector easily by using Pythagoras theorem, which says x square equal to c square equal to x square plus y square. Okay, basically height, we have to multiply our height twice and the base twice, so we can get the hypotenuse of that right angle triangle, or the thing you want, or the length of the vector. Okay, so I hope you get the idea how you can use vectors to move any game object the point you want. Okay, you just have to get the x value and the y value. You have to pass the x value, x axis value, and the y axis value, and then you can find the length of that vector. I guess we don't need to find the length of the vector in the game. Instead we have to get the x axis and the y axis. Okay, and we can move that game object anywhere we want, okay, in our scene view. So I hope you get the idea how vectors works. Okay, and it has direction, so that's why we can move the game object in the direction we want. By using our vectors, we can move our game object to negative side, so we can put x to -1, and we know -1 will be over here. So if I put, so this is negative side and this is over here is positive side. Okay, so we can just move that game object to the negative side as well. We know vector has a direction, so that is the cool thing. Okay, we can move the game object anywhere we want, or any direction we want to want. We just wanna move our game object by using a vector. Okay, so next thing we will cover up trigonometry. Okay, how you can find an angle and real life application. Okay, uh, I hope you get the idea. Okay.